Alrighty. Yeah. Okay. What is happening, Hazelton? 403 to the HAZ. Mr. Nelson here. I want to keep this. I think this can be a quick video. Okay. So we've been introduced to functions and relations, and we know that a function is a type of relation where there is only one output, one specific output for each specific input. Okay, that's what makes it a function. And a function will pass the vertical line test in a graph because you're not going to have, that vertical line is only ever going to cross one data point as you move it across. It's never going to cross two data points because crossing two data points with a vertical line means that we have two different outputs, y's, for the same input on the x-axis. X's are almost always considered our inputs, and y is always, most of the time, considered an output. It's just kind of the way we got into dealing with those variables or representations. It's just how we do it. Just accept it, swallow it. Just eat that. Terrible choice of words, but let's just keep going. Digest it. Okay, just accept it. Where's my block? Okay, there we go. So let's imagine. I want you to imagine. Okay, we have. I've got a function or a relation where for each input I'm going to double it and add 1. Okay, so you can imagine. Okay, so we're going to be dealing with x's and y's. Okay. And I'm just choosing some random inputs, okay? Just random numbers. I'm gonna go -2, -1, 0, 1, 2. I'm just choosing those at random. And I said that the relation is that my y's are basically, I'm doubling my input and adding 1. So if I doubled -2, I would be at -4, and then if I add a +1, I'd be at -3. At -1, I double it, -2, and then I add a +1 back to -1. 0 times 2 is 0, plus 1. 1 times 2 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5, okay? So I've created a table of values for that relationship. Now, I can actually represent that relationship algebraically using my y's and my x's, where I can say that y is equal to 2 times my input x, so 2 times x, 2x, that means 2 times my variable x, plus 1. And what this means is that for each y, or for each x I choose, my corresponding y will be equal to 2 times that x plus 1. Okay? This is, we'll learn this later, but this is my slope-intercept form. And that's coming in soon enough. Now, so basically I could choose any number of x, and to figure out the corresponding data point y for that x, I just plug it into here. Now, function notations, I can represent y many different ways. I can say, y is a function of x, okay? So y is a function of x. Okay, which means that whatever's in the bracket here is my input. So I could say that the same way I said y is equal to 2x plus 1, I could say my function of x is equal to 2x plus 1. Okay, x is my input, f is my output. I could have also said that y as a function of x is equal to 2x plus 1. Okay, when I have my output, my f or my y, that's my output, with brackets with an x inside, that means that x is my input, y is my output. And my input, I'm going to substitute in my equation. So if I said, what is the function value, if somebody said, what is f of 2 for this function, or for this function? Well, f2 means that every time you see an x, you're going to replace it with that 2, with the input. Because now I'm saying, this is the general, sorry, I'm talking really fast. This is the general function for any x. But now we're going to find out, okay, what is the output when my input is 2? What's my output when my input is 2? So I go 2, x is 2 now, plus 1. So my function output when my input is 2 is equal to 5. What's my function output when x is equal to 0? Well, it's 2 times 0 plus 1, or 1, okay? So in the textbook, they talk about function notation. So they'll say, so maybe they'll give you something like p is equal to 3q minus 5, okay? This is an equation in 2 variables, and p is going to equal whatever q is, whatever the input is, times 3 minus 5. Now, if they said, how would you write this in function notation? Well, I would say my output p, which is a function of q, which means it's dependent on q. That's my independent variable. P is my dependent. P depends on whatever q is equal to 3q minus 5. These are 2 different ways of representing the same thing. And in this case, they want, and so I could also say that this is a function of q. I could also say this is a function as of q, but in this case, we can just say p of q. Function comes later. As we move forward, we start to get away from most letters, and we start to really just deal with y is equal to a function of x, right? So we really just start to deal with y is equal to 2x minus 1, or we'll talk about a function of x is equal to 2x minus 1. But we just need to know that when we see an f, it means a function with an input of q. And the function, the f, is going to be the output. The q in the brackets is going to be the input. And this will kind of, you'll start to kind of get a sense of it down the road. So the other thing that we can do is, let's just keep working with this function here. What if they said, if f of x from this function, if it is equal to 6, what input gives me an output of 6 from this equation? Well, in that case, I can rewrite this. If f of x is equal to 6, I can say 6 is equal to 2x plus 1. And then I can solve for x. Now, I don't know how much algebra those of you out there in the universe, in the math universe, have done, but that's something that we'll work on, is actually just solving for x, because that's something we need to do. And algebra has its own little tricks and tools that we can work on. So that deserves its own video. But basically, what I do to one side, I have to do to the other, and I'm going to try and solve for x to figure out what x gives me an output of 6 in this equation. So the first thing I do is I'm going to subtract 1 from each side. Whatever I do to one side, I have to do to the other. And I'm trying to isolate for x. So in doing that, I get 5 is now equal to 2x, because this goes away. Now the opposite of multiplying is dividing. So to get that x alone, I'm going to divide both sides by 2, and I get x is equal to 5 halves. So I have an output, so basically this could be written as a data point of 5 halves as my input, 6 is my output. Okay? And I could have rewritten this graph as function of x. That's my output. F of x is my output, x is my input. X is my input. Okay? Hopefully that's enough to get you going.